Greetings, everyone. Welcome to video session here, where we're going to describe something called the linear method. What this is, it is a series of steps that will allow you to take data, results, information from an experiment, and through this process, figure out the equation for that data, for those results. That allows you to relate the dependent and independent variables together with one another. Now, in order to do this, there are a few things that you have to bring back into your mind, and that is first of all, the parent graphs that we talked about a couple days ago. Those were all the pictures of the graphs and then the functions of x that went along with them. Parabola is x squared, square root is square root x, hyperbola 1 over x, we had log, sine, a whole bunch of them. Okay, so that page current in your brain would be useful. And second of all, the functions that go along with the pictures. Yeah, as I just said, x squared with the parabola, for example. So you need that. We need to find the slope of a line, so we need to have the slope equation nearby. And then what I'm going to show in particular is there's a particular step that I'm pretty sure might cause some trouble. So I'm going to take a close look at this, and then when once these are completed, we'll get on to solving a proper problem from start to finish, so you can see how it works and what it does. So, a reminder of the parent graphs and parent functions that we saw the other day. So these are 3 of them, and I'm going to suggest probably the 3 ones that we're going to use in class, or at least 3 of them that we're going to see. There are more, as you saw, so depending on your future situations, you might use them, but for now we got these. So, just a reminder that a shape, when it's like a U, the graph is a parabola. When the shape is, someone described this as an eyebrow once. So, okay, shape's like an eyebrow, square root function. And when the shape is like this, ski heel maybe, half pipe, it's called a hyperbola. Now, for you grade 12s, this shape is actually coming from rational functions, which for this graph actually has a second part down there that mirrors it. But for the physics that we're doing here, we're not going to be using that, not seeing that, or it's unlikely. So I'm just going to leave it out to keep the pictures clear. What you do have to know are the functions that go along with these pictures. So, said it twice on the earlier slide. For parabola, the y values are related to x squared values. For the square root, the eyebrow, that is related to the square root of x. And for the hyperbola, this is where the rational function comes in grade 12s. Rational fraction. This is related to 1 over x. Sometimes 1 over x squared, higher powers, but for us, 1 over x. Now, during the process, we're going to have to do something called, or a step that involves updating x. which actually means changing it from the original value in the experiment to one of the parent functions that we were just looking at. So I'm going to pretend, this is a shortened version of part of a solution. I'm going to pretend that we have these x values and then some y values that go along with it. They don't matter right now. And I'm also going to pretend that when we graph these out, which is part of the step, I'm going to pretend that we get our quadratic that we talked about. What you should recognize, as we just said, that it's related to x squared. And so now we have to update the x values for the next step in this process with x squared. So the update we're going to do to get a new set of points comes from the shape that we see from our original graph. So the update is going to be with x squared. So that means, what do? Well, we take all the original x's that are here and we square them. So you take minus 2 times minus 2 gives a plus 4. You take the minus 1 squared, that gives a plus 1. 0 squared gives a 0. And the same thing on the other side. 1 squared is 1. 2 squared is 4. So what we've done is we've updated the x coordinates from the original to x coordinates that now match the shape on the graph. And what we will do is use the new values that we get in this table here to create a graph and continue through the process to get to the final equation. Okay, so I'm going to stop there. We'll go on to the next video and I'll show you from start to finish the steps that are needed in order to find the equation for a set of data that looks something like this. See you soon.